Good morning, I'm Mr. Precella with my Math 1325 class, and today we are trying to, we're not trying, we are looking at some absolute extreme on a closed interval. Here's the problem we're going to do. Find the absolute maximum and absolute minimum on the given interval for the function f of x equals x divided by x squared plus 1. I'm going to rewrite that just because it seems too small to me. I'm a big writer. X divided by x squared plus 1, and we're on the interval from -2 to +2. So we'll find our critical numbers. That means we have to find f prime. Are we going to need to find f double prime in this problem? No, for local extrema, absolute extrema, I only use the first derivative. So what are we going to have to do to differentiate this function? The quotient rule, because we have a quotient of x. I agree, we'll need to use the quotient rule. That means we need the derivative of the numerator and the derivative of the denominator. What's the derivative of the numerator? Let's just write that off there. 1. The derivative of the denominator, 2x. So using the quotient rule, we get y prime, or f prime of x. I'll just out of laziness say y prime equals, it's the derivative of the first, 1, times the second, that denominator, x squared plus 1, sine minus the derivative of the denominator, 2x, times the original numerator, all over
x squared plus 1 squared.
Okay, x squared plus 1 quantity squared. And we can clean that up a little bit. That is, let's see, that's what, a x squared plus 1 minus a 2x squared. 2x times x, that gives me that minus 2x squared. And let's see, that gives me y prime equals x squared minus 2x squared. That's a minus x squared. I think I'll write it as 1 minus x squared all over x squared plus 1 quantity squared. We need to know, when is this derivative equal to 0? When is it undefined? Well, we know when the derivative is undefined. When is a fraction undefined? When the denominator is 0. Is that denominator ever going to be 0? No. So even though there's a fraction appearing here, it's never going to be undefined. It's certainly not going to be undefined on the interval from negative. It's always defined. Let me word it like that. So we don't have to worry about that undefined situation. Now, when is y prime equal to 0? When is a fraction equal to 0? When the numerator is equal to 0. So I better write all this stuff down. When is y prime equal to 0? That's when the numerator is 0. When 1 minus x squared is equal to 0. And 1 minus x squared is equal to 0. Know something? Why don't we factor this? That's a difference of 2 squares. That's 1 plus x times 1 minus x. So I'm getting two different critical numbers. What are they? Here, okay, when x is -1, 1 plus x is equal to 0 at -1. When is 1 minus x equal to 0? When x is +1. So we have two different critical numbers. Okay, so, and let's go ahead and make a note. I'd asked also a class sitting in here everything just looks black and white or gray and white, doesn't it? But on the video, there's color, okay? So once I upload it to YouTube, there should be color. And so I'm switching over to purple now. When did y'all say when is y prime undefined? That's a scribble there. When the denominator's 0, when is that x squared plus 1 quantity squared equal to 0? Does that ever happen? No. So when is y prime undefined? Never. Since this function is continuous on a closed interval, it's continuous for all real numbers, but it's certainly continuous at that closed interval up here, -2 to +2. That means there has to be a maximum y value, there has to be a minimum y value, and those extrema have to occur either at the endpoints of the interval or at my two critical numbers. So we're going to make a table. Give me, someone has an extra sheet of paper. Okay. Thank you. Okay. So I'm going to make myself a table. I have my x values. Let's see. X values. I'm going to make a table. And my y value is, what was the function? X divided by x squared plus 1. I have to plug in -2, -1, +1, and +2. Which one of these numbers gives the biggest, or which of these numbers give the biggest y value? Which give the smallest y value? Okay, plugging in -2, what are we going to get? We'll get y equals, that'll be a -2 divided by, that'll be a 4 plus 1 is 5. So at -2, the y value is -2/5. Maybe that'll be the absolute minimum, I'm not sure. Let's plug in -1. We'll get y equals, that'll be a -1 all over. 1 plus 1 is 2. Plugging in +1, we get y equals, that'll be a 1 over, another 2, yeah. And plugging in 2, we're going to get a y value of 2 over 5. Well, which one of these y values is the largest? Which one is the smallest? I'll give you a hint. One of these two here is the absolute minimum. Which one? I think that -1/2, that would be what, 5/10? -2/5 is -4/10. I think that's a 0.4 and a -0.4 and a -0.5. -1/2 is smaller, so there's my absolute minimum y value. Okay, what's the absolute maximum y value? 1/2 is larger. If you doubt, just think in terms of decimals for those fractions. Any questions so far? So now we come over here. Let's go back to our to the original problem. Make sure we answer the question they asked. Okay, here's the original problem. They want to know the absolute maximum is and the absolute minimum is. They say to type an integer or a fraction. Realize they're not saying the absolute maximum is at x equals. They're wanting the maximum value and the minimum value. That means the maximum y value. So the maximum y value was 1/2. The minimum y value was -1/2. Oh, look at that. The absolute extrema occurred at the critical numbers. Any questions? Okay, I'm going to take a break. Bye. Where's that? Oh, there.